So a parabola passes through the 3 points shown in the graph. Oops. Okay. Write a system of equations, A, that can be, jeez. Okay. Write a system of equations that can be used to find the equation of the parabola in the form f of x equals ax squared plus bx plus c. Okay. Perfect. So here, I have been given 3 points of a parabola, right? Each of these is an x and a y coordinate, right? The equation that I want to come up with eventually is y equals ax squared plus bx plus c, all right? Now, what I need to do is I need to plug in every single one of these into this equation. Okay, so here's how this is going to look. For the first one, right, 1 comma 4, x is 1, y is 4. So here I say 4 equals a 1 squared plus b times 1 plus c, right? Now let's do the same thing for the second point. Negative 5 equals a times negative 2 squared plus b times negative 2 plus c. And finally, for the third one, negative 6 equals a negative 1 squared plus b times negative 1 plus c. Okay, let's simplify these equations. So the first one, I get a plus b plus c. It's still 3 variables. Instead of x, y, z, it's now a, b, c. But I'm going to write it with the variables first equal to the constants. So a plus b plus c equals 4. For the second one, I have 4a minus 2b plus c equals negative 5. Then I have a minus b plus c equals negative 6. This is a system of equations that can be used to find the parabola, right? So this is part A. When I solve this, what do I solve for? I solve for A, B, and C. And A, B, and C are the unknowns that I need in my quadratic equation to come up with the equation for this parabola. The equation for this parabola is going to look something like, 3x squared minus 2x minus 5 or whatever, right? So that's what it is. So do you see how that is now just a system of equations problem? Okay? So let's move on. Part B, use matrices to solve the equation, the system of equations that you wrote in part A. So for part B, I'm going to transform this into a matrix. 1, 1, 1, 4, 4, negative 2, 1, negative 5, 1, negative 1, 1, negative 6. Okay. All right, so what does that turn into now? Okay, so how am I going to get rid of this first one? Yeah, I'm going to do row 1 minus row 3. So I'm going to get 0, 0, no, 2, 0, and then 10. Okay, next one. I mean, that already solves it for you, right? But let's just do another one just for practice. How do you get rid of this 4? What? Minus R2, right? So 4 plus 2 is 6. 3, 16 minus 5, no, 21, right? Because you know from here that 2y equals 10, so y equals 5. That's what we said in that last problem. as well that we did, that you were asking the question on. Okay. It'll say. Okay, so X, so here we have 1, 1, 1, 4. Okay. So to put this into row echelon form, you would have to get rid of this, right, and make it a 0. Okay, but we're not gonna bother with that right now. So from that, so this last equation, I get that 2y is equal to 10. So y is equal to 5. Oh, shoot, C, yes. Thank you. Ah, B. Oh my gosh. We're stuck in like variable purgatory there. Okay, so B equals 5. So then from the blue row, 6B plus 3C equals 21. So what is that? 30 plus 3C equals 21. So 3C equals negative 9. C equals negative 3. Is that right? And then A plus B, which is plus 5, minus 3 equals 4. So how much is A? 2. Okay. Am I done? No. Well, let's go back to the problem. So use matrices to solve the system of equations. So the solution technically to this is 2, 5, negative 3. But then part C says, now write an equation of the parabola. So the equation of the parabola, remember we had to have it in the form f of x equal to blah, blah, blah. So the equation of the parabola is going to be f of x is equal to 2x squared plus 5x minus 3. That is the final answer to 54. Okay? Now, if I purposely added another day on your lesson plan to be able to solve problems from the homework, and if I specifically went over this one, where do you think this problem is going to show up? Or maybe both, quiz and test, okay? So, because at the end of the day, we're doing this to be able to apply the things that we're solving, okay?